Good morning, dear students. Today we will continue with part 2 of chapter 11, that is human eye and colorful world. Clear? Up to this we have completed total internal reflection and dispersion of light. I hope you have understood it better, and I hope you have written the daily life application of total internal reflection. It is known as TOI, total internal reflection. Now today we will start with the concept that is scattering of light. Today's first concept is scattering of light. Clear? So what is scattering of light? Now we will see in detail. Scattering of light means it is the phenomenon by which the initial path of incident ray is changed by particular angle is known as scattering of light. See, if the incident rays are parallel, and by here, suppose in atmosphere some particles are present. In atmosphere, some dust particles, smoke particles, fog particles, water droplets are present. See, in our environment, some of the minute particles are present, that is fog, smoke, dust particles, okay, pollutants. See, if incident light ray comes in a straight path and after striking with this particle, they change their original path. Is known as scattering of light. What is the scattering of light? Scattering of light is a phenomenon in which the initial path of incident light rays is changed after striking with the dust particles, after striking with any particles. Or we can say, if incident light ray collide with any dust particle, it change its path. Its initial path is known as scattering of light. Clear? Is known as scattering of light, and this effect is known as Tyndall effect. Now, why it is known as Tyndall effect? Because a scientist named Tyndall first observed this type of effect, okay, and he observed this type of concept, this type of diverging of incident ray is observed first by Tyndall, and therefore it is known as Tyndall effect. Clear? So again I am repeating, what is scattering of light? Scattering of light means the divergence of the diverging path, okay, the divergent path by the small dust particles. Clear? When the incident light ray strike with the small dust particle, the incident light ray will diverge from its original path, is known as scattering of light. Clear? Now we'll move towards the daily life applications of the scattering of light, total internal reflection and dispersion of light. Okay, daily life application. Daily life applications related to the concept scattering of light, total internal reflection and dispersion of light. Clear? So what is daily life application? The first application is formation of rainbow. Formation of rainbow. Clear? Now we are going to see how the rainbow is formed. See, in rainy season, in our environment, some water droplets are present. In rainy season, in an environment, some water droplets are present. For example, this is a water droplet. a water droplet is present in our environment, see the light from the sun, white light, the light ray from the sun, when it enters into the water droplet, see this is rare medium and this is denser medium. Water droplet is denser medium. Clear? So rare to denser, white light when enter from rare to denser, for example this is normal, So according to our first rule, when a light ray enter from rare to denser, it will bend away from rare to denser, it will bend towards the normal, For example, see this is a normal, for example. Now the white light should travel straight, but because it enters from rare to denser, so according to the first rule, it will bend away from towards the normal. Rare to denser towards the normal. Denser to rare away from the normal. So rare to denser, so it will bend towards the normal. Now what is this? This is the dispersion of light. Ray. See, white light after entering into the water droplets, the white light is dispersed into its 7 color. The white light will disperse into its 7 color. Clear? The white light will disperse from its or into its 7 color. Now see, this 7 color of light after striking with this surface, this is the surface of water droplet. They will again bounce back. Why? Because here the concept of total internal reflection. Is followed. Clear? Now see, this white light is spreading into its 7 color. So this is known as dispersion. Now this white light rays after dispersing into 7 color, this light ray is striking on this surface and bounce back again, okay, or we can say it is reflected again, which is known as total internal reflection. And when they will come out, we can see the different colors of light, and this is known as rainbow. Clear? Rainbow. Now see how the rainbow is formed. When the white light enters from rare to denser medium. When it enters from rare to denser medium, the white light spread into its 7 color, which is known as dispersion. Now this 7 color will, after striking with the internal part of the water droplets, they will again bounce back. They will again reflect into their previous direction. Now here a total at this position, angle of incident is greater than critical angle. At this position, angle of incident is greater than critical angle. Therefore, total internal reflection is obtained. And by this they will spread or they will bounce back again into the color. And after coming out, we can see the different colors of light. And which is seen as rainbow. See, and there are 2 conditions for the formation of, or to see how to see the rainbow. There are 2 conditions for seeing the rainbow. The observer should be, or we can say that the observer should stand in front of the water droplets, or we can say the water droplets should be in front of the observer and the sun should be behind the observer. The sun should behind the observer. Clear? If I am standing like this, then the water droplet should be in front of me and the sun rays should be coming from my behind side, from my back side. So to see the rainbow, suppose this is my position and the water droplet should be there in this direction and sun should be in this direction. So when the sun rays coming and after striking with the water droplets, if they will come with me or towards me by the spreading into 7 colors by the total internal reflection, I can see the rainbow. Therefore, most of the cases, 99.99% rainbow is formed in the rainy season only, whenever there is a moisture present. Whenever there is moisture present in the atmosphere, then only we can see the rainbow. Clear? Now the next daily life application is second daily life application is twinkling of stars. How we can see the stars are twinkling? Twinkling of stars. Now, for example, this is our Earth and this is atmospheric layer. This is an atmospheric layer. Clear? Now, on the Earth there are two layers. Okay, here a layer of hot air, which is rare medium, and cool air, denser medium. Okay, the cool air are denser. Clear? Now see. On our Earth, there are two layers, that is hot air and cool air. Hot air is slightly, what we can say, less in weight. Okay, hot air is less in weight, therefore it is at the above surface of our environment, and cool air is heavier than cool air is heavier than the hot air, therefore it is on the first layer of the atmosphere. See, this is our Earth. For example, this is Earth. So, hot air and cool air. Now, suppose here star is present. This is a star. Now see, when a light ray travels from star, okay. Now, see, this is a rare medium and this is denser medium. This is rare medium, hot air and cool air. This is denser medium. Now I will draw a perpendicular plane. Clear? Then what we can see from rare to denser medium. When incident light ray enters from rare to denser medium, it bent towards the normal. Clear? Suppose here an observer is standing. Here there is an observer on the Earth. Now see, the light rays from the stars is entered first in the rare medium, then from rare to denser medium. So from rare to denser medium, the incident light rays is bent towards the normal. So the observer feels that the light ray is coming from this direction. Okay. See, actual position. This is the actual position of star, and this is apparent position. Clear? So here, if observer stands on the Earth and from the star, if a white light travels and it enters from rare to denser medium, hot air, rare medium, and cool air, denser medium. So the white light travels in a straight path, and according to our first rule, when it enters from rare to denser medium, it bends towards the normal. It bends towards the normal. So the direction of light ray is changed. The direction of incident ray has been changed. Now, what observer feels that? Observer feels that the light rays is coming in this direction. The light rays coming in this direction. So the observer feels that the star is at here. The position of star is here, but this is apparent position of star. Actual position of stars is this. Therefore, we can see the stars are twinkling. Now, the main concept why the stars are twinkles. Why the stars are twinkles? Now, the stars twinkles because see, the atmosphere of Earth is not rigid. Okay, it continuously moves. The airs are continuously movable. Okay, the airs are continuously moves. Air continuously moves. It is not rigid. The atmosphere of Earth is not rigid. It is continuously moves. It is continuously changed. Clear? So when it changes, so sometimes we can see the star here, and sometimes we can see the star here. Sometime here and sometime here. So by this way, the stars appear like they are twinkles. Okay, we can feel the stars are twinkling because at first position or at a first instant we can see the star is here. At second instant we feel the star is here. Again, when the atmosphere changes, this direction also changes with the atmosphere. When the air moves, this direction of light rays also moves, and we can feel that star is here. And at second instant directly we can see the star is here. That means we feel that the stars are twinkling continuously. So this is the reason why the stars are twinkling. Now what is this concept is known as, see, incident light that comes in this direction. This is the concept of refraction. This is the concept of refraction. This is the concept of refraction of light. Clear? Now the third daily life application is why sun appear reddish. Okay, why sun appear reddish? Now, why sun appear reddish? Suppose this is Earth. And this is the atmosphere of Earth atmosphere. Clear? Now, suppose this is a direction of east and this is west. Now the question is, why sun appear reddish at sunrise and sunset? Why sun appear reddish at the time of sunrise and sunset? Now see, suppose a sun is present here. Okay. Now, when the sun light rays is coming in straight direction, from rare to denser medium. From rare to denser medium it comes. So here the dust particles are present. So when this white light scatters, when this white light is strike with this dust particle, when this white light of sun after striking with the dust particle, it scatters in different colors. Now see, from here to here this much distance, clear? So it travels this much distance and here it scatters. Now, as I have told you that violet, indigo, blue, green, yellow and orange. So the red light is having highest wavelength. Okay, when all the light scatters, clear, when all the light scatters, only red light can transfer to the earth. Rest of all light is scatters. Because the wavelength of red light is the highest among the 7 colors. Okay, and here at west, when the sun rays, this same phenomenon is followed. When the white light is coming, here dust particles are present. When the sun rays is coming in this direction, after striking with dust particle, all the light rays is scattered. But only a red light can transfer towards the earth, because it is having the highest wavelength. Therefore, at the time of sunrise and sunset, it appears red in color. Clear? It appears red in color. And the fourth and final application is why sky appears blue. Why sky appears blue. Okay, so again same, suppose this is earth and this is the atmosphere, clear. Now the white light from the sun, and when it enters into the earth atmosphere, so all the light, which are there, all the light colors will pure: violet, indigo, blue, green, yellow, orange and red. See, these three colors having less wavelength, and this color yellow, orange and red having the higher wavelength. So when the white light from the sun enters into the earth atmosphere, and when it strikes with the dust particle, the light which is having the less wavelength is spread. The light having the less wavelength will be spread. They will scatter here. Okay, they will scatter. But the light having yellow, orange and red wavelength will not scatter by this dust particle, and they will come towards the earth. Therefore, here two concept arises. Therefore, sky appears blue because blue color scatters most. Due to less wavelength. When sun rays enters into the earth atmosphere after striking with the dust particle, the blue color, violet, indigo and blue color scatters. In the atmosphere. Therefore, the sky appears blue. And second thing, this question can be asked like why sun appears, or why the sunlight is white, or why we can see the red color light of sun is coming towards the earth. So this is the reason. So the why sky appears blue, because blue color is having the less wavelength, so it will scatter first. Now if the blue color scatters, because of the scattering of blue color, because it is having less wavelength, sky appears blue. Clear? I hope you have understood all the daily life examples or daily life application. Now your homework is the question number 1. Why traffic signals are red in color? Why color of clouds is white? And question number 3, why? Okay, 2 questions is enough. So these 2 questions are the homework that we'll discuss on the time of Google meeting. Why traffic signals are red in color? Why color of cloud is white. Why color of cloud is white? And one more question, why school bus, why school buses are yellow in color? Yellow in color. Okay, these three questions is the homework. Clear? I hope you have understood what we have discussed today. Now that was all for the chapter 11, Human Eye and Colorful World. Clear? This much only is there for your examination. Okay? Thank you.